Hey guys, and welcome to Chem Squad Chemistry. This is Mr. Mullins today. We are going to be covering Dalton's Law of partial pressures along with the ideal gas law. Today we're going to be doing work straight out of the book, so you're going to need that. Your unit book, which is beige in color for most of us, and is Unit 11, the gas laws book. So we're going to be on page 4 talking about Dalton's Law of partial pressures to get started. So Dalton's law of partial pressures tells us that the total pressure of a gas is the sum of the presence of all of its parts. So if you were to imagine that you have, like, let's say, a mason jar that is completely sealed off at the top, so nothing can get in and nothing can get out. And into this mason jar, we insert some gases. Let's say that we take some oxygen gas and we put it in there, and it raises the pressure to 1.3 atmospheres, right? And now you might wonder, what is the pressure inside of the jar? Well, since oxygen gas is the only thing in there, it would just be 1.3 atmospheres. But what happens if we were to add something else, like let's say nitrogen gas? Let's say I put 2.3 atmospheres of nitrogen gas in there. What would be the total pressure inside of the jar? This is a simple math problem. We know that if nitrogen gas is 2.3 and the oxygen gas is 1.3, we can just simply add those up. So 1.3 plus 2.3, that's going to give us 3.6 atmospheres. That's basically what Dalton's law is telling us, is that we can add up all of the partial pressures of a gas in a container, and that will equal us to the total pressure. And that comes in formula form, which is pretty simple to write down, so you need to go ahead and try to remember this. That is that the pressure total, I'm just going to write a T for total, is equal to the sum of all of the parts. So you might have, 3 parts, and we would write it as this, where A, B, and C are variables, and the capital P stand for pressure. Lots of times you see it written with dots after that, because if you have 4, 5, 6, you would continue on the pressure of D plus the pressure of E plus the pressure of F. So this is Dalton's law of partial pressures, and it helps us to calculate the partial pressure of all of the gases. So each one of these are individual gases, and we know that if we add all of them up, it's going to give us the total pressure. So we're going to do a couple of example problems. We're going to be on page 4 at number 1. So on page 4, number 1, it says a mixture of oxygen gas, carbon dioxide gas, and nitrogen gas has a total pressure of, let me write this down real quick, total pressure of 0.97 atmospheres. What is the partial pressure of oxygen? So we're looking for the pressure of oxygen gas. What is the partial pressure of oxygen if the partial pressure of carbon dioxide is 0.70 atm and the partial pressure of nitrogen is 0.12 atm? So they told us carbon dioxide's pressure, they told us nitrogen's pressure, and they want us to find the pressure of oxygen. So this is going to bring us back to Dalton's law, where the total pressure is equal to the pressure of all of the different gases added up, so the sum of all of the pressures. So we're simply just going to start plugging these in. We know that the total pressure is 0.97 atmospheres, so we're going to plug that in. I'll write all my work down here. We've got 0.97 atmospheres, and that's going to be equal to the pressure of oxygen, which we're looking for, plus the pressure of CO2, which is 0.70 atmospheres, plus the pressure of nitrogen, which is 0.12 atmospheres. And all we have to do now is simply solve for the pressure of oxygen. So we see that the mathematical operation that's holding these variables together is addition. So all we have to do is simply subtract. So we have 0.97. We're going to subtract 0.70 and 0.12, and this gives me an answer of the pressure of oxygen is equal to 0.15 atmospheres. So very simple, gives us the answer there. Just a simple little addition or subtraction problem. Let's move on and try number 2. Number 2 states, what is the partial pressure of hydrogen gas in a mixture of hydrogen and helium? if the total pressure is 600 millimeters mercury and the partial pressure of helium is 439 millimeters mercury. So they tell us that we have this mixture of hydrogen and helium, and they tell us that the total pressure of them together is 600 millimeters mercury. They also tell us that the partial pressure of helium is 439 millimeters mercury. Ask us what is the pressure of hydrogen. So we go back to Dalton's law, where the total pressure is equal to the sum of the two parts, and in this case we only have two parts. We're going to plug in the pressure of hydrogen for one of them, and we've got the pressure for helium for the other one, and that is equal to our total pressure, which they gave us, 600 millimeters mercury. And again, this is going to be a simple subtraction problem. 600 minus 439 is equal to 161 millimeters mercury, and that's going to be our pressure of hydrogen. If you would, pause the video now and try questions 3 and 4 on your own, making sure to use the correct number of sig figs. Again, pause the video now and try questions 3 and 4. If you have not already completed questions 3 and 4, please do so on your own before we try together. Number 3 says, find the total pressure of a mixture that contains 4 gases. So we know that we're looking for the total pressure, and we know that it's going to have 4 gases. So it's going to be A plus B plus C plus D. Now we just need to assign them there. And they tell us that the pressure is 5 kPa, 4.56 kPa, 3.02 kPa, and 1.20 kPa. So we need to simply add all of those together. We've got 5.00 kPa plus 4.56 kPa. Remember, kPa stands for kilopascal. We have 3.02 kPa. And lastly, we have 1.20 kPa. So all of these are going to add up to our total pressure. Remember that when adding, it's not about the sig figs, it's about the number of decimal places. We can see all of these have 2 decimal places, so our answer must have 2 decimal places. Looks like our total pressure is going to be 13.78 kPa. Moving right along, we're going to try problem number 4. Problem number 4 states, find the partial pressure of CO2 in a gas mixture with a total pressure of, so they told us the total pressure is 30.4 kPa. If the partial pressures of the other 2 gases in the mixture are 16.5 kPa and 3.7 kPa. They're asking us to find the pressure of CO2. So we can assign both of these. Let's call them pressure A and pressure B, and we can plug them right into Dalton's law, where we can figure out what the pressure of the CO2 is. So we're going to plug this number in, plug this number in, and we're just going to simply subtract. So if you subtract these, you get 10.2 kPa, and that is our pressure for CO2. And there you have it for Dalton's law. If you would like more practice on this, please do all of the practice problems on page 4. Thank you and have a great day.